Welcome to today's Explainer. Let's jump right into this because honestly, we're standing at the edge of a massive shift in how we understand artificial intelligence. For years, right, the whole story of AI has basically been about its ability to answer incredibly hard questions. But today, we're looking at the next frontier. We're talking about a leap from simply solving complex problems to fundamentally discovering which problems are actually worth asking in the first place. And this is a huge deal for us. AI isn't just going to spit out answers anymore. It's going to completely change the very questions you're asking in your own field.
So here's our roadmap for today. We're going to cover AI as a problem solver, AI as a scientist, 4 sources of questions, knowledge is not discovery, the constrained novelty spectrum, and finally, the scientific discovery loop. Let's get to it.
Starting off with Section 1, AI as a problem solver. This is our baseline.
So right now, AI is a ridiculously powerful problem solver. But look at the structure we're used to. The human defines the problem. We spoon-feed the AI a fixed target, right? A predefined problem, a known objective, existing evidence, and exactly what measurable success looks like. But a true scientific intelligence, it has to construct the problem itself. To act like a real scientist, it needs to sift through this massive, messy field of data, examining fragmented knowledge, contradictions, anomalies, and missing causal links, just to figure out what the target even is. It's like building the bullseye before you shoot the arrow.
Moving on to Section 2, AI as a scientist. The paradigm shift.
We're literally shifting from answering questions to creating better questions. This central leap in intelligence is absolutely monumental. It's moving away from just, retrieving knowledge or running massive calculations and moving towards structurally diagnosing what an entire scientific field is completely missing. Think about it. It's about recognizing when researchers have built their whole careers around a convenient question while entirely ignoring a much deeper, more fundamental one.
Which brings us to Section 3, 4 sources of questions, categorizing the unknowns. So where exactly do these transformative structural questions even come from? Well, we have 4 major sources. First up is contradiction. When 2 findings clash, a normal AI might just average them out, right? But an AI scientist asks, wait, what hidden variable makes both of these true? Second is the anomaly. Instead of just brushing off an exception to statistical noise, the AI asks, is this exception actually revealing a deeper mechanism? Third, unexplained regularity. When things just keep happening together, the AI asks, what mechanism is producing this exact pattern? And fourth, excessive complexity. If a field is relying on ridiculously complicated procedures just to keep a theory on life support, the AI steps back and asks, hey, is this problem being represented using the completely wrong variable? These tensions aren't just errors, they're structural clues.
All right, Section 4. Knowledge is not discovery. Structural insight.
I want you to just take a second and really let this statement land. A library contains knowledge. A scientist identifies what the knowledge fails to explain. There's this massive assumption out there that if you just feed a model enough data, like if it memorizes literally every medical journal or material science database in existence, it's just going to automatically generate discoveries. But volume does not equal discovery. A massive database doesn't wake up and decide that a widely accepted assumption needs to be challenged. It takes a completely different kind of capability to realize that actually researchers might be optimizing the totally wrong variable. Because true discovery fundamentally requires reorganizing that knowledge. An AI scientist has to take scattered facts and transform them into a structural map. It has to categorize things into established claims, weak assumptions, contradictions, missing mechanisms, unresolved questions, and ultimately testable hypotheses. It literally has to map out exactly where our human understanding is fragile or just assuming way too much.
Let's move to Section 5, the constrained novelty spectrum, balancing outputs. To do this right, the AI has to balance its judgment across the spectrum. Look at the far left. If a model stays too close to existing knowledge, the outputs are just, incremental and obvious. Boring, right? But on the far right, if it moves way too far from existing knowledge, it just generates ideas that are purely speculative and completely unverifiable. True scientific intelligence has to live right in that narrow middle region. We call this the scientific discovery zone, or constrained novelty. This is where a hypothesis is highly novel, it's consequential, and it's testable. It remains strictly accountable to actual evidence.
So here's the crucial takeaway. Unusual is not the same as important. Any basic generative model can easily smash distant concepts together and invent some highly unusual, speculative story. That's just randomness. It's a parlor trick.
But formulating a constrained question that forces an entire scientific field to measure or model reality differently, now that is the true hallmark of discovery.
To actually find these important questions, an AI can use what we call the energetic paradigm to look at causality. Take medicine, for example. Instead of just asking what drug fixes a symptom, the AI looks for structural inefficiencies. It asks things like, what underlying mechanism reproduces the observed condition? Is there a hidden cost being transferred somewhere else? Is there a constraint being continuously maintained? Or maybe a feedback loop preserving instability? It hunts for a variable that explains persistence or accumulation rather than just settling for an inefficient explanation that consumes excessive complexity. It completely shifts the target.
And that brings us to our final section, Section 6, the scientific discovery loop, the recursive process.
In the first half of this loop, the AI starts by doing the homework, understanding existing knowledge. Then, it has to identify a structural gap. From there, it formulates a question, generates hypotheses, and derives predictions. It absolutely has to use broad knowledge and deep causal reasoning here to push way past surface-level correlations. Then we get to the testing phase. The AI must gather evidence, test those hypotheses, revise the model, and, here's the kicker, reconsider whether the original question was even correct. In real science, things almost never go perfectly from an initial question straight to an answer. More often than not, the evidence proves that the initial framing was totally malformed from the get-go.
The question itself may need to change based on evidence. And honestly, this is perhaps the single most essential capability of an AI scientist, the ability to recognize when an assumed category is just flat out wrong. It's that breakthrough moment when the AI tells us that the overarching problem doesn't just need solving, it needs a total ground-up rewrite. Let's compare these two paradigms one last time just to really cement this mental model. The solver operates on the rigid belief that the question is fixed. But the scientist operates on the reality that the question evolves under evidence. The ultimate output of real scientific intelligence isn't just an answer, it's a vastly improved structure of inquiry.
I want to leave you with this incredibly provocative thought. A genuine discovery model does not only produce answers humans did not know, it reveals problems humans did not know they needed to solve. That is the exact moment AI transitions from being just a handy tool within science to becoming an active participant in creating it. Take a second to think about the implications of that and how it might completely reshape your own industry. Thanks so much for joining me on this explainer today, and I really hope this changes how you view the future of intelligence.